to you, and welcome.
Yeah, thank you so much, and thank you for being here. I think this is an outcome of my having attended the first Berkeley bsac Women Alumni event, which was really fun, and I couldn't stop talking about it. So it turned into this invitation here to talk again about climate. So as John kindly said, I've been teaching this class at Stanford, and I'm giving my homage to Stanford. It wants me to unmute myself. Giving my homage here because a lot of the slides you'll see are ones that I've been using in my first 2 weeks of class this quarter. So there's that, but I know the difference, and bsac is where I learned BIMS, and I think BIMS could have so much to do with the climate crisis. It could really help a lot. So how many of you, you're all in BIMS, right? That's why you're here. Right? So, yeah. So I don't have to explain to you. What we found is that some of my electrical engineering students at Stanford didn't know what BIMS was, so it's fallen off the radar a bit there. Excuse me. But the things that really could be helped with are getting people out of harm's way, basically, because the world is changing. And this is, you know, people who know their climate and know their environment, they still get in great trouble. And this beautiful photo from the Boston Globe is of an expert hiker who was taking a hike recently, just this last weekend, with his, well, I guess with his daughter on his back was not, you know, the condition when he was on his hike. But he left at 9 a.m. He hadn't returned by 2 hours after they expected him back, so by 10 p.m. And he died because there was an extreme cold snap. There were extreme conditions. And you think about that, you think about this guy, apparently everybody loved him. He had a family, he was just a really happy person. And he's gone now, way too soon. And what could you do in the way of sensing to help him? He found soon enough to help somebody realize his body temperature was dropping, or he'd fallen, or whatever happens. I don't know. But this is real life people. And so these things that we are thinking about, you know, what could we do with them? They really have a purpose. If you have more, I asked years ago a Coast Guard person who was giving a talk about, you know, the hazards of all these rising seas and these, you know, harsher storm conditions these days. And I said, have you tried a wide area network? I was here when Chris Peaster was starting all this storm work, you know, and make lower cost sensors, you know, much more easily than most other ways you can think of in the world. And the Coast Guard guy, it's like I was speaking in some very foreign tongue for them. Like, what? Like, what? How could you not be thinking of that if you're trying to predict things and get people out of harm's way? I've been at some conferences, a conference in New Orleans, where they gave us a tour of the flooding and talked about the fact that so many people died there, mostly of low income, because they hadn't gotten work. It just didn't come. So there are some very simple things you could think of that could help people a lot and could, of course, these are essential things. These are things people should pay for. Then this increased monitoring and reporting of the Earth's changing conditions. What I'm finding, even this year, even with my students at Stanford who decided to sign up for something with a depressing title like Engineering, Entrepreneurship, and Climate Change, you know, they walk in the room, you can tell they're worried. It's why they take the class. And they were shocked by how quickly the positive feedback loops are happening. You know, as ice melts, more ice melts, it melts faster. And what that's led to now. So that's a problem. And this big news that's just going all over the place, you know, trying to defend somebody's profits or trying just to muddy the water so nobody has to change anything. If you had your own personal sensor for CO2 level or something, you know, and you could every day look and say, whoa, it rose again. You know, I don't care what they say on the news. This is true. That's the kind of thing. There were some scientists in India, I believe, who, the only way they could make the point that they had so much particulate pollution, which is really terrible, was by taking their data out of the country to conferences. The government did not want that shit. Those were back then. So you can actually empower people to know what the heck is happening. And then when you know that things are about to break, right? There's a lot of damage happening from glacial lake outburst flooding in mountainous regions. When you know what's about to happen, when you can detect something, you've got room again for new sensing modalities, for things that just make them cheaper and better than they were. And then there's lower energy solutions. I'm seeing some really interesting work that could really lower the power requirements for some essential things that are right now power products. So how do we get onto that? Well, what your friend here has been doing, looking at this and saying, wow, there's so many ways. Can we cite fires better, right? Can we see that they're happening? Can we do something about droughts and low productivity agriculture because of climate change? What about this? When you've got high storm surges, it's mainly the water that's doing it, right? And what are you going to do about that? So how on earth did we get here? Well, the CO2 levels have been rising, and everybody's been screaming, the only thing we should do about climate is get rid of the CO2, and yet it's been rising every year nonetheless. So politics hasn't been doing that for us. Oil companies way back were proud. Of course, at this point, they thought we were going into the next ice age, so maybe they were okay to be proud on this. This was Exxon's predecessor, Humble. Each day, we supply enough energy to melt 7 million tons of glacier. They're advertising. What we know now is that the melting of the ice, this used to be our bright reflective ice shield that reflected so much of the summer sun in the 24-hour-a-day sunlight that hits the Arctic in the summer. Temperature is now rising at many times that of the rest of the world. I forget if it's 3 times faster or 4 times faster. This is a positive feedback. And it's what I've decided to work on, because you can do something at relatively small scale, relatively nature-based and simple, and make a difference in a leverage point. So positive feedback loops are important to look at. What's getting worse and worse and worse than it happens? And so I'm not going to spend a lot of time on this, but just over these last few decades, the NASA video now is the best one out there. Just the last few decades, right, from 1984 to 2019, we've gone from having this much bright reflective older ice to this much in the Arctic. That's amazing. The other way this gets described is it's been accelerating the warming by 1.5, by a factor of 1. What it would have been had the ice stayed in place. It's also, so a positive feedback loop is a bad thing. And now, as we look at that, methane is getting a chance to come out of the permafrost as it melts, come out from under ice shelves as they go away, much faster than before. Detecting methane, there was a prof at Stanford doing a lot of work on trying to find methane a few years ago, because methane, which is also called natural gas, is a much more severe pollutant per molecule than CO2. It doesn't hang around as long as CO2, but it's much more dire while it's there. We've got maybe, the scientists are now saying, maybe 10 years left to have enough time to make the difference that we need to make. All of these. And so this is these are real, urgent problems that have crept up on people, because most people, you guys are technically trained, so you've got it. What happens with an exponential curve? It keeps compounding itself and rising. But that's not in most. And I've been reading, articles that tell me most people don't understand what's happening in science, that a peer-reviewed process says many people have checked your work, that it's reliable, that we don't get paid for publishing articles. We have to pay to get them in the journals. All the work that it takes to get the job done. At this point, I'm not doing this through a nonprofit. I haven't found a good other way to get this done. A lot of that's come out of my pocket. Once you do your small scale experiments, you can feed them into climate models, and you can see that you can make an enormous difference in that same area of the Arctic we were looking at by treating an area like this and letting it spread and grow over time to that. So much more bright ice could happen if you trust the climate models, and we work with a good group. So we're taking away our solar shield, we're adding methane the least risk, and methane is 80 times more potent than CO2 within, a span of 10 years, which is the time. So that's why I've been focusing on albedo. There's a lot of other ways to focus on albedo, which is brightness, reflectivity, but that's the deal. How does CO2 cause global warming? Probably beyond what we've got time for here today. You're right that I don't have that. Still good. So if you get curious about that, this Columbia Climate School has the most coherent explanation. Why is CO2 so bad? If you're curious, you might want to see that. CO2, one of the things and why people have concentrated on it so much is once it's there, it's lifetimes long. Perhaps more. So it's with us. So if we stopped all CO2 emissions today, it would still go up because our atmosphere, the temperature of the atmosphere is still equilibrating to what the new composition we made the atmosphere is. So it's something to worry about. We're getting attention. NOAA, the National Oceanic and Atmospheric Administration, has been documenting how much monetary damage is coming from this. And it's terrible, right? This was in 2021. They just listed, and with basically the location, how many billion-dollar weather and climate disasters there were. There were a lot. People don't tend to want to hear about this, so they don't know about it. Again, sensing, being able to not just look at a satellite image, which of course is sensors through, of ice changing in the Arctic, which is the most potent visual, I think, we have to show people what's going on. But if you could take your little personal CO2 detector and see what's going on, I think that really would help people. Ignore the fake news and help add to the but it's worse than you think just from that somewhat pretty picture, because this too is accelerated. Feedback loops keep feeding on themselves, things get worse. So it's already cost us trillions of dollars just in one country in the world, the US. The average over this 1980 to 2021 year period, 7.4 events, 361 deaths, $51.4 billion. Where does it come from? A lot of it's just loss, right? It doesn't get made up. People are losing things. And then just a few years later, the 2021 in the US alone during that 1 year, and it's showing that it had accelerated, many more deaths, many more costs. And what's happening now is perhaps, the latest year that they have data for, 2023, we're a little lower on the deaths and the cost, but we're higher on the events. So we may be beginning to get a little better at the resilience and early warning what to do, which is what we were doing. So people used to consider, in fact, the COP that just finished, COP 28, and the IPCC reports, still talk a lot about we got to do things by 2050. Nonsense. If we don't get things done pretty quickly within this decade, life's going to be a lot harder for everybody and everything on this planet than it has to. We can just get the will and the funding and the techniques to do something about it. So insufficient action has been really pretty bad. And life-threatening problems now, how will we cope? I love this little book by John Cooney. He teaches at Stanford too. Not sure full-time, but a fair amount. And he wrote a book called Cold Cash, Cold Climate. Or maybe it was the other order, but at any rate, some little quotes from him is, entrepreneurs can look for opportunities. That's what I'm trying to encourage you guys to do. MEMS could become a mighty force in this to help people see the truth, to help document things, perhaps to help reverse and sense things, or at least help people more inexpensively through the research phase of development. And so rather than as one simplified response, entrepreneurs, you know how it goes. You try something, you see if it works. You do it in a small, safe, inexpensive enough manner. That's one of the great learnings I got from Professor White, who was my PhD advisor, is to be able to figure these things out in an inexpensive, simple way fast. And then you can get all the detailed work that's going to get you your peer-reviewed publication that lets people see, oh, this is for real. As the next step that takes a lot longer. So let's try things. You know, make sure they're safe, but try things. Business needs environmentalists, environmentalists need business. Start small, think big, get going. I have internalized this as my mantra. But you need to understand some things. I feel, I haven't said this a lot to the scientists intentionally, but I feel a bit sorry for scientists generally, because they get to see in great detail the demise of these conditions, the demise of ecosystems, and they are trained. I mean, I heard years ago when somebody was talking about the record low ice in the Arctic. It doesn't fit my model. I've got to go back and work on my model. It's like, that's your takeaway? What I find much more exciting, and if you think like I think, if you happen to be that way, I love coming up with solutions. I love asking questions which can range from ridiculous to profound. And I'm not sensitive about that anymore. Some of the things I've invented have had big impacts. That gives you a little bit of confidence over time. But it's, you know, you ask the question of, is there a bright reflective material that could help ice stay longer? That's the thing that has powered my work over a decade now, trying to preserve ice. That's the question. And then you figure out, well, what would that look like? How can I do that? Wait, that's in my wheelhouse, my skill set, because I did a minor in materials. So, you know, I thought, okay, let's figure this out. So there are things that you can do as an engineer that scientists are discouraged from doing. And it gives you hope. You're able to look this in the eye and say, okay, what's the next problem now? What's the real problem here? And there's a lot of other factors. It's got to take into account what policies are. Are they discouraging or encouraging you to be able to do this? AGU, the American Geophysical Union, is great at helping to create the framework for this that I've been longing for from the beginning. We need to have decisions made in the service of humanity, and that's not just people who have your privilege of being here at Berkeley or have the privilege of being at Stanford, or, you know, it's everybody, especially the people who are going to be affected by what you're trying in the region where they live. Really have to consider everybody. And let's consider the ecosystems while we're at it, because without what has been here for all of this time with humanity on Earth, you could have a dead rock here, right? So engineering, bringing solutions, collaborate with everybody you find who has, you know, a reasonable voice in this, and everybody who's interested is really, it's a lot of work, but it's a good thing. And if you work localized way, there are some plans, you know, people have. Excuse me, I guess we're both going to be glad I'm not paranoid enough to be burning this all the time still. But I think it's just a tickle. Getting back to, some people are really interested in trying to do some treatment. The entire atmosphere, or maybe the entire ocean is the fear of treating a little bit. Okay, those things may never get off the ground because a lot of people are saying, wait, didn't science mess this up in the first place? Didn't technology, do we really want to do that? My problem with it mainly is there's no undo switch. If you're not humble enough to try something to say, I want to be able to detect any problem immediately, or, you know, within a week or two, before it spreads, and I want to have an undo switch. I think that's the only way we can do that. And so I'm really in favor of localized interventions. You'll hear some you know, other approaches that try to go more globally. And so with this, I've been thinking about the frameworks even before AGU now has adopted a beautiful one of just who do you have have to consider, and it's a lot of stakeholders. This is us up in the Arctic, up about as high, about as far north as you can get in the U.S. And you've got a lot that you have to do. It isn't just the technology. If you're trying to do a climate intervention, if you're trying to build a sensor that's going to let people know the situation better, you've got a lot less of this framework that you're going to have to worry about. But you might want to make it usable for people who live in the areas that have the most friendly. So it isn't just the engineering. We know this. This is what we actually do. Take a little powdery material, looks like sand, happens to float, hollow glass microspheres. It's mostly air or gas. It means that you get a really immense change in reflectivity by spreading this pretty widespread material. I mean, it's used in a lot of building applications and highway markings and things like this already. So it's being made in big quantities already. Spread that over something, over ice that's formed but is not, doesn't have snow on it. Even with snow on it, this helps. And you can see an immediate change in albedo. And we've done a lot of testing on a homeowner's pond with some retirees from one of the companies that makes these materials. I went searching there on purpose. And it's been terrific to see what exactly this stuff does. When we get back to the sensors, we have to instrument this a lot. That's what a lot of the cost of these things are in order to make enough determination of does it work, is it effective, is it practical, is it harmless, to make a determination of whether it's actually working. And improvements in sensors would save things a lot. But the sorts of things that we look at, temperature, what's the incoming and outgoing radiation in the shortwave and longwave lengths, and that helps the climate modelers decide, would this be a beneficial thing? Would there be some unintended consequence, many miles away, some other country, if people did this at a larger scale? So that sort of thing really matters. We found we decreased this. There's drone footage from overhead, again, for sensors, lightweight would help with drone, what a drone can carry, the way of sensing package. This is what we had over the course of this season. The treated side, the untreated side, and then month after month after month. Things, it works. It decreased the amount by about 30%. And if you want to not wipe out ecosystems, you don't want to shift things very quickly. Part of what is having more species die off is that conditions are changing too quickly. Changing them back, you also don't want to make a big rebound effect. Well, that's what that looks like. Here's what the climatomatics climate modeling looks like. I think it's just a matter of, I like to hike, and my brother is a wonderful outdoorsman, much better than I am at that. But we went on a very tough hike that ended in 3 thunderstorms and a moose. And this is what the folks up there on that trail think of as a trail, refrigerator-sized rocks. But what it really comes down to is, if not me, who, as you're doing anything hard, if not me, who, if not now, when, just keep taking that next right step. Some of these things I'm asking you to consider are going to be really hard. Some of them are going to be embarrassingly simple. When I got to tell my Stanford students, we're still okay. When I got to tell my Stanford students last year who were asking me about what about these innovations, how embarrassingly simple some of them were, that is how it can start. So one of the things, the inkjet work that you kindly talked about, that helped get a large format inkjet printing into the market that had been stalled because they couldn't refill their ink quickly enough. And what did it take? It took me not listening to what the original problem I was supposed to be going up there to our inkjet printing to solve, but going back to a textbook and saying, but they say they can't refill that, and it's holding up $1 billion product line. Oh my goodness. And finding in chapter 1 of the fluid flow text that I had, the concept, which worked really well, of flared channels and what happens to fluid flow. You can do some pretty simple things with that. And in my thesis, it happened I was refilling, capillary action, refilling channels as part of what I was doing my thesis with. So it was like, the insight doesn't have to be a Maxwell equation, times 6. No, it can be a very simple insight. And don't be afraid of those, of thinking them through. And then test them, of course. And you might want to test them before you say them aloud. I find that to be a really fun thing in my own life. So that was the questions, right? Is there a safe material? Could glacial ice melt be slowed? Because while people are fearing that things might go global, I had originally aimed at sea ice. Photos, those satellite imagery over time, sea ice is a dire problem. But it does have the worry with it. Well, what if it goes global? Got asked to work on Himalayan ice because they have a big problem with their agriculture, floods, and lack of water. I mean, it's a mess. Third Pakistan is underwater. An entire country. And so, and people claim, is it millions or billions who are affected? Both those numbers are big enough for me. We get to work with people who actually live in the region, have expertise in the region, are environmental impact assessment specialists in the region. And so that's a good way to work. And hopefully will help eventually, clear the way for maybe we could do something on sea ice as well. But it requires a new material. There you are in Silicon Valley thoughts, right? Oh, gotta pivot. What's it gonna take? Because the materials we've used on flat ice are all natural glacier. So what do we do there? And we've got a good clay-based material now that doesn't roll as fast, but it still gets displaced after a while, after the meltwater's enough. So I'm working on a completely different thread right now, how to keep that in place. And to me, that's the fun of the job. Greenland is losing a lot of ice. Greenland, you hear a lot about sea level rise because of that. And that's going to be a big loss for the world too. There's so much of humanity living in coastal areas and don't have anywhere else to go. And if you start wiping out where people can live and their homes and their land and their food and their livelihoods, I'm afraid I think we're going to be ending up with endless war if we don't do something much better. And that's not what I want my kids. That's who I live for, But it's them, your generation, you're at the same ages. It's not going to be pretty if we don't do something. So there are a number of people around the world, and this is what keeps me going, that have really great solutions they're working on. And I think this is how we can do this, is collaborate with as many as you can fit, they're not going to distract you, but you get to have the power of working together. That's really, I think this is quite useful. Here's a list of some ideas that I think might be quite useful that you can get to in NEMS, in addition to the ones we started with. And I think it's worth thinking about. And remember, this is what I tell my Stanford students, with the pandemic and with all the pressures that you have when you're in college, it gets hard to feel healthy, spiritually or physically at times, right? And I'm really trying to encourage them, and I encourage you to do the same thing with each other. Collaborate with each other. Don't just, if you're feeling overwhelmed by the reality of something, get together. It's the way to survive this. It's the way to do something, survive, thrive, and help. So start by learning about other efforts, and I think that was it. So there's lots more I could say, but let's stop it there and see what's on your mind. So somebody's got to have a question. I saw some very attentive eyes. Oh, thank you for drinking the ice. So it's good.
Yeah. So, I think obviously a lot of what maybe all of what is funding a lot of this work is government, right? Foundations, things like that. And nonprofits, as you mentioned, and things. But it seems to me like one thing that can accelerate a lot of this way to make money and corporations. So what kind of examples, or they already exist, or how commercialized to do some of this stuff, either the monitoring or obviously turn the monitoring into some gases or something, whether they can be monitored.
I think there can be a partnership between the governmental funding, the policy, and the use. And if you think about that poor heartbroken community with that spectacular, youngish guy with a very young kid, harsh because the weather conditions got bad. And I think about my elderly parents, they're 94 and 95. There's a lot of the same sort of monitoring that we could use for both. Hey, if you turn this on, if you know that you're maybe in trouble or you're running late, you turn it on if you want to, respect privacy. And you see that his body temperature is dropping or that he's not moved in a while, then you know to call somebody else. And I would think that families seeing an example like that would probably just pay whatever they had to get something like that in the hands of that. And I know for my folks, I'm delighted my dad has finally agreed to have a falling monitor, but there's so much more that you can do. There's a lot of people, need things like that, not just expeditioners and not just old people. Be a really worthy market. And I know years ago in the Clean Tech Open, when I went to that to see what people were doing, there were some really worthy efforts there. I don't know where they got. I suspect if you covered these with Medicare, you could perhaps be able to get more of these types of sensors for elderly people and in better shape. So that's one example. As far as the rest of that with policy goes, if we actually could find companies for emitting, for letting methane, or, just all the disingenuousness, right? That would be phenomenal, and that would give you the funding to have the sensors there, so that any citizen watchdog group or any governmental watchdog group try to enforce that. Back in those days at Chevron, they were depending a lot on gas chromatographs to see whether it was their gasoline or somebody else's, because everybody has their own special thing. What I was working on was trying to get the lead out of gasoline. So what are substitutes for that? But every oil company has their own group. And once you can attribute, well, no, that was Exxon's, not Chevron's, you've got something. If you follow that up with suing or finding the company that has been emitting this, you've got, again, the funding to make things better. What I got excited about when I started at HP was in MEMS, we were working on a miniaturized gas chromatograph. And I was like, yes, that's a way, again, you're carrying the information to individuals it's a way to figure out what's going on. So I think those are some simple ones to think about. There's a lot in the energy field, I think, that's just going untapped. If you know how to wrap fluids, there's, and MEMS, microtechnology, microfluidic systems in particular, would make some interesting impacts. And I give away one of my favorite ideas here right now, but if you decide to get excited about this, tell me about it. I'd love to collaborate with you. But if you could more efficiently use these sorts of things, these sorts of characteristics, to be able to water your crops more efficiently, get the right fertilizer, not overwater, right? That might be breakthrough. And we're going to be needing food. Our fish stocks are dying, our agriculture is getting messed up, out of phase. What's the temperature for growing versus when the water is coming down from the belt, there's a lot of things that if we can make them more efficient, these increasingly scarce, precious resources that are talking about back to New Orleans, which I think about a lot. That whole BP oil spill and the whole, apparently it isn't just that area. It's just a lot of the agricultural Midwest has horrific pollution in their drinking water. If you can clean up, protect what's there. You can save a lot of needless health issues and, do what we're supposed to be doing, preserve the resources that we have had the luxury of growing up with, that we've researched. So, just as a few examples. And we'll wait two at once.
I was wondering if you could comment on the use of sensors to validate carbon capture schemes.
That would be very useful. You want to be sure, of course, with all of these, that you've got some credible groups producing these sensors. There's a lot of attempts to be looking at methane emissions from satellite imagery. I don't know how well that's working, but it's a worthy idea. And there's a lot that can be carried on satellites and on drones that can be very helpful. Did you have a question before you go?
No.
All right. Thanks. Bill, you had your hand up too.
Yeah, you've been studying the ice issue for many years, and could you talk more about the albedo effect? I'm curious, two things. One is, does it require large concentrated areas, or do small spots across the planet make a difference? And the other is, does it reach a level of diminishing returns? Because as we have the CO2 cap and the heat trapping aspect, though we're radiating more heat from the planet, are we just increasing the temperature of the atmosphere, and so it has a diminishing return? But rather than focusing on just protecting ice, is there indication that it's smart to add reflective materials, whether it's rooftops and roadways and everything else on the rest of the planet?
Great question. I'll start with the last one. Yes, on the rooftops. Yes, there are heat deaths in India these days. If anybody's read, it's a long read, Kim Stanley Robinson's The Ministry for the Future. Right, yeah. I mean, good Lord. And I have friends who have relatives who did, actually one within our consulting group who have relatives who have been dying from that. That's not pretty, right? And yeah, just the temperature getting too hot for humans to survive. Yikes. And that, to give away a bit of the plot, is the hardest part of the plot. That's the beginning of that book, that long book. It gets better. It's actually a science fiction utopian, and he's trying to tell us what technology get us out of this. But yeah. So that's dreadful. And reflective roofs help a lot, apparently. And making more reflectivity and more greenery in your cities helps a lot. There was a beautiful thing, one of the most credible scientists and politicians in the world, Sir David King, over in the UK, who has been the chief science advisor to the UK for a long time, has this whole thing on, I saw it on a LinkedIn video, on the absolute need for whale poop. And it's like, what? I mean, this is a very serious scientist, but it's a great reminder to look back to nature for what was happening, right? Before we interfered with it, before people started killing whales for food, which actually gives you much less economic income than just letting them swim around in the ocean and do what they do. Because whale poop is, as he described it, when they're way down deep under feeding, they can't poop, right? The pressure is too much. You can't do that. So you come towards the surface, all of a sudden you can, and you've got this layer of high nutrient that allows the phytoplankton and then the fish stocks to grow. And, just simple insights like that are just more of what we need, I think. So the albedo could be with choice of crops. The albedo could be with simple solutions like ours. Whether locally it can help, we're asking. That's what we're finding out we've done now a glacial test in Iceland, and we're almost, I'm told we're almost at the point of getting the permissions in India to do some glacial tests. This is the point of why do we need to do research and why do we need to do tests? You don't know if it works until you tested it. And what we know so far is we still have farther to go to make sure our stuff isn't just washing downhill. And we have the environmental impact assessments look real good. We got to collaborate with the experts from the Himalayas, but that's a very important thing. But we also need it to be effective. And And the climate modelers, this has been part of why I've been working with them for years. I mean, it's not cheap to work with climate modelers. They've got huge infrastructure they have to pay for, you know, unless you've got a government grant covering it, it can be an expensive enterprise. But the main question is, what specific region would most benefit? And is there another region somewhere, you know, in the mix that will be worse off if you will? So those are questions we're still asking. It looks like, certainly from the CIC, you know, results that they've shown, and they've shown to a very high confidence level, that, you know, there are areas that could be particularly important. I like that. That's lower risk for everybody as well. I bet we're out of time, but if not, yeah. This is about no
Other questions?
But yeah, if you've got questions, I'd love to answer. Those were great ones. No, not just because we've known each other for decades. Anybody else curious about any of this? Inspired anybody? Okay, there's a mild nod or two. Yeah, think about it. You know what I found in my Stanford class this year was the first lecture. Several students writing, I have them write an essay every time, and several students writing, if not me, who? If not now, when? I'm going to remember that the rest of my life. Okay, so guys, keep that mantra. It's what's empowering you. Thanks a lot.
So you're a speaker.